Hello everyone, and this is Mathematic, and in this lesson I will talk about natural, whole, and rational numbers. Alright, so first let's discuss what are natural numbers. A natural number is just a positive integer, like 1, 2, 3, 4, 5, and so on. There are also rules regarding natural numbers. So whenever we add or multiply two natural numbers, our answer will always be a natural number. However, whenever we subtract two natural numbers or divide one by another, our answer will not always be a natural number. Now let's talk about whole numbers. Whole numbers is a set of numbers which includes positive and negative integers, including 0. There are also rules regarding the whole numbers. Whenever we add, subtract, or multiply two whole numbers, our answer will always be a whole number. However, whenever we divide one whole number by another whole number, we don't always get an answer as a whole number. The next type of numbers we will talk about is called rational numbers. All rational numbers are written in the m over n format, where m stands for a whole number and n stands for a natural number. The denominator of the rational number cannot equal to 0, since the denominator is a natural number. Every whole number is a rational number and can be written as m over 1. Now let's discuss some rules regarding the rational numbers. So whenever we add, subtract, multiply, or divide two rational numbers, we get a rational number as our answer. The only exception that applies to rational numbers is that we cannot get a rational number if the denominator equals to 0. If you can imagine a rational number being written in the m over 10 to the power of k format, where m is a whole number and k is a natural number, using this form we can turn our rational number into a decimal. For example, here we have a rational number 327 over 100, and we can write this number as 3.27. Here's another example. Here we have a rational number 2 over 5, and it is the same thing as 4 over 10. We can write this number as 0.4. However, there are rational numbers like 1 over 3, 1 over 9, or 3 over 7, which are really difficult to write in a decimal form. Let's look at the rational number 1 over 3. The problem we have with this number is that its decimal form is continuous, and it will be written as 0.333333 and so on. Alright, now let's do a practice problem. This problem is asking us to write 27 over 11 as a continuous decimal. In order to turn a fraction into a decimal, we have to do long division. Alright, so first we have to draw the division angle. I usually write the dividend on the left and the divisor at the top right. Next, what we have to do is to subtract the closest multiple of 11 from 27. In our case, we have to subtract 22. We write 2 in the bottom right because 11 times 2 is 22, and our difference will equal to 5. After the 2 we have to put a point because 5 cannot be fully divided by 11. In order to do so, we have to add a 0 to the 5. The closest multiple of 11 to 50 is 44, so we subtract 44. We add 4 to our answer and our difference is 6. So now we bring down 0. The closest multiple of 11 to 60 is 55, so we add 5 to our answer and the difference will be 5. Once again, we bring down the 0. The closest multiple of 11 to 50 is 44, so we add 4 to our answer and the difference is 6. Again, we bring down the 0. The closest multiple of 11 to 60 is 55, so we subtract 55 from 60, we add 5 to our answer and our difference is 5. So we can do this long division process for an infinite amount of time, and our answer will be a really long decimal. So from the things we had done, we can conclude that 27 over 11 is 2.4545 and so on. As you see, I put the parentheses around the 4 and a 5. In Matthew, you write the parentheses around the repeating digits in the continuous decimal to save time. If you think about it, every digit can be written as a continuous decimal. For example, here we have 27, and we can write it as 27.00000 and so on. Or we can write it as 27.0 and put parentheses around the 0. Here's another example, 3.74. It can be written as 3.74000 and so on. Or we can write it as 3.740 and put the parentheses around the 0. Okay, let's do a second example. So here we have to add 2 over 11 plus 1 over 9 and turn it into decimal format. So first we have to add the two fractions. So to add two fractions, we have to find the common denominator. So the common denominator will be 99. So 2 over 11 turns into 18 over 99, and 1 over 9 turns to 11 over 99. So when we add two fractions together, our answer will be 29 over 99. So now we can do long division. So first we write the division angle, and we write 29 over 99. So since 29 is not divisible by 99, we write 0 to our answer. Now we can add a 0 to 29 and make it 290, and subtract 198 from 290, and our difference will be 92. And we can write 2 to our answer, and we subtract 891 from 920, and our answer will be 29. And we can write 9 to our answer. So we add another 0 and subtract 198, and we add 2 to our answer, and our difference will be 92. Now we add another 0 and we subtract 891, and our difference will be 29, and we add 9 to our answer. So now we notice the continuous decimal, and we can conclude that 2 over 11 plus 1 over 9 equals to 0.29. So we write the parentheses around the 29 because it's a continuous decimal. If you enjoyed this video and found it helpful, please like this video and subscribe to my channel.